Welcome back to the Lowdown on Physics. This is part 2 on projectile motions. Today we'll be looking at oblique projection. This is where we're launching it on an angle. So we are now in the process of launching a projectile off on an angle, and then we're going to analyse what's happening to the motion in each of these situations. So as we can see, we can look at what's happening vertically, we can look at what's happening horizontally, and how the motion's going to change. So no point trying to consider this as one motion, horizontal and vertical components always. So the vertical motion. You have an initial velocity of u, we've got negative g for our acceleration. We have final velocity of negative u, that's as long as it's impacting at the same point. So we can use minus u equals u minus gt. That is simply v equals u plus at. Then you can solve for t if that's what you're looking for time of flight. In the horizontal direction, you have it moving at constant velocity. So we've got our range equals ut, where u and v are going to be the same because it doesn't change. So that's our range there, sometimes written as delta x, where delta just means change in. So change in x displacement or horizontal displacement. So let's look at some examples here. We've got Rubina. She's standing on Ballarat. She's on the express train. She's travelling at 30 meters per second. She throws an orange vertically upwards as far as it is to her. Goes up at 4 meters per second, and then she catches it again at the same height when it comes down. So firstly, how long is the orange in the air? So this is simply a vertical motion problem. There's no horizontal motion in this instance. So simply it's going up at 4 meters per second, and it comes back and it stops at negative 4 meters per second. So we know u, we know v, you know a, because this is vertical. We want t, so we use v equals u plus at. Substitute in, minus 4 equals 4, take 10t, collect like terms, solve. We get 8/10 of a second, or 0.8 seconds. Usually we answer in decimals in physics because fractions really are somewhat can be meaningless. Like 8/10 is meaningful, but if you've got 37 over 65, what's that actually mean? It's more meaningful to us as a decimal. So we'd write that as 0.8 seconds. Okay, so how far did the train travel while the orange was in the air? So the train's moving at 30 meters per second. The orange has been in the air for 0.8 of a second. There's no acceleration because we're now talking horizontal. So we want the distance, which is the velocity times time. Substituting in 30 times 0.8, which is 24 meters. So for somebody who was standing and observing from, say, a platform, that's the motion that the orange would have carried for that person that was observing it from outside the train. So we've now gone from just a vertical motion to an oblique motion. Okay, how far did the orange rise inside the train? So we know it left at 4 meters per second. We want to know h. We know the velocity at the peak is 0 meters per second. So you can use v squared equals u squared plus 2ax to solve this problem, where a is negative 10. Alternatively, we know, well, let's finish this, 0 equals 4 squared minus 2 times 10 times h. So solving, we get 16 over 20, or 0.8 meters. Alternatively, we know that the whole time of flight was 0.8 seconds. So we know that it took 0.4 seconds to get to the peak, and you could use x equals ut plus a half at squared. This is probably marginally simpler to solve it, but there are two ways to solve that problem given the information that we've now worked out. So now we can extend that to what happens if, instead of somebody on a moving object launches it vertically, to what happens when we launch the object at the angle. So we have some angle theta that it's launched at, and it will then, due to gravity, follow that parabolic motion where it will eventually crash back down. So we need to analyze that in terms of vector components. This is cos, this is the side attached to theta, so this UH, this is the initial horizontal velocity, will be v cos theta. The vertical component, uv, will be v sine theta. Okay, so we've got an example here. We've got a golfer plays a pitch shot. That means it's hit at a sharp angle, and he hits the ball at 20 meters per second. There's an angle of 60 degrees. What are the initial components for velocity and horizontal and vertical? So vertical component, that's going to be sine theta. So 20 sine 60, it's about 17.3 meters per second. Horizontally, you've got v cos 60. So it's going to be 20 times cos 60, which is 10 meters per second for horizontal velocity. Okay, find the time of flight of the ball. So firstly, look at your variables. You know the vertical. Time of flight's always about your vertical motion. You know vertical component of your velocity. You know A. You know the velocity at impact is going to be opposite, assuming that we're landing at the exact same height. You want t, so v equals u plus at would be the obvious equation to use to solve that problem there. So substituting in, rearranging, we get 3.46 seconds that it's in the air. Okay, find the horizontal distance travelled by the ball. So this is velocity times time of flight. So UH equals VH equals 10 meters per second. We know the time is 3.46 seconds. So substituting in, 10 times 3.46 means that it travels 34.6 meters. Maximum height. You have initial vertical velocity, 17.3. You know g should be negative 10. You know v final velocity will be 0 at the peak. You want x, so v squared equals u squared plus 2ax. Substituting in, we've got 0 equals 17.3 squared, take 20x. So rearrange to solve, we get a maximum height of 14.96 meters.